Okay, so here's our next video involving an object that is released from an inclined plane. Okay, so here's a problem, or here's a scenario where we have an object that is released on an inclined plane. Inclined plane, if you notice, I mentioned the word inclined plane because the plane is not along the horizontal axis. So it means that it is inclined at a certain angle theta. Now we all know that when there's no friction, when it's smooth, there's nothing preventing it from not moving. So unless there is an applied force, or I'm pushing it here, or something is holding it from the other side, like a tension or a spring that is preventing it from sliding. However, this time it's all dependent on friction, but friction is not there, so definitely will start to move. So this block will move towards the lower part of the incline. So it will slide down. Okay, slide down. So from an initial velocity of 0, now you have a velocity that is not 0. Okay, so it's not 0. So the acceleration might be to the left. The velocity is to the left, same direction as the motion. So let's see how to calculate or to attack this kind of scenario. So first technique, of course, is to do your free body diagram. Free body diagram. And again, when we work on a free body diagram, let's have our x and y coordinates. So the imaginary Cartesian coordinate system that the intersect is actually our reference dot. Now again, just like what I mentioned in our previous video, it is the x-axis should be parallel with the plane, or the horizontal axis should be parallel with the plane. So it means that we have to rotate our axis, rotate our Cartesian coordinate system, and that is rotated at an angle theta measured from the horizontal axis or foundation of the earth. So this is our x-axis, this is our y-axis, and the intersect is our dot. The dot will move or not move, and then we have our, yes, it is moving, the dot is moving, or the whole block is moving. And there is what we call force of gravity, or weight, Fg. And then, just like in the previous video, there is a normal force that is preventing it from going straight down to the plane. But this time we have it at an angle, okay, at an angle which is similar to our y-axis. So this is your F sub n, or the normal force. There's no friction, okay? There's no friction and there's no other applied force, so the only forces acting here are the force of gravity, or the weight, and the normal force. Okay, so there's two different forces, and by looking at it, okay, by looking at this scenario, you would say right away that there is a change in motion because there is nothing holding the opposing another force at equal magnitude. Okay, so before we move on, let's just redraw it. As soon as you see it in your next section of the free body diagram, you might be able to see that scenario that I'm talking about. So we have our free body diagram with force of gravity going down, and that force of gravity is mass times g. And then we have our normal force, which is towards this direction. So normal force, Fn. And then of course, allow me to just draw this as part of our x and y coordinates. So if this is our y-axis and this is our x-axis, you notice right away that we have components for Fg, and then we have our y, and so this is your Fgy, And right here we have our FG X. Trying to look for the correct color, FGX. Okay. And again, if you notice, the angle is measured along the y-axis and not along the x-axis. So by what we have been doing, since it's measured from the x-axis or from the y-axis, we will be using for our y component the sine function for the cosine function, and for the horizontal component or the x component to be our sine function. Also, since FG is mg, we can immediately change this to mg sine theta and mg cosine theta. Expanding it further, we can draw another dot right here with our free body diagram. We have the normal force Fn, and the normal force is being opposed by the y component. So this is Fg y, and then moving towards this direction is your Fg x. So Fgx, Fn, and Fgy. So there's nothing opposing our horizontal force because of gravity. So therefore, it will definitely move. So it will definitely move. So now let's start, or let's continue with the solution by applying our concept of law of motion and our mathematical skills. First one, let's use the summation of forces along the y-axis, which means that mass multiplied by the acceleration along the y-axis. Again, let us analyze the acceleration. So if we analyze accelerations, since there's no movement along the y-axis, so it means that the block will not penetrate the plane. There's no movement along the y-axis, so we can say that the acceleration along the y-axis is 0, while along the x-axis, where we all know that the block will slide down, with the absence of friction, so with the absence of friction, it will be moving towards the left direction. Okay, so it will be considered A, and since it is increasing from 0 to not 0 anymore, so it will start from rest when I place the block and it will slide on its own. So this one could be considered as positive acceleration, since it is increasing in terms of speed from 0, and that's our basis of assigning the positive acceleration. So summation of forces along the y-axis, where positive is upward and downward is negative. So we can say that the normal force is simply equivalent or minus Fgy, or the component of force of gravity along the y-axis multiplied by mass and the acceleration 0. Now we can say that F sub n, or the normal force, minus our Fgy, which is, from what we know, Fgy is our cosine function, and that is 0. Now we can say that Fn is simply equivalent to negative Fg, or now it's on the other side of the equation, so this will change into positive. Gy got too excited. And we can say that the normal force is simply equivalent to the mass multiplied by acceleration due to gravity, or the gravitational field strength multiplied by the function cosine Then let's place the angle theta. Fn is mg cosine theta. Now, this is not something that we want to solve for. We want to solve for the acceleration. So using our blue ink, so we can say that the summation of forces along the x-axis is equivalent to mass times the acceleration x. Going to the right is positive, going to the left is negative, so we have negative Fg of x, and there's no other force acting on it, multiplied by the mass and the acceleration positive a. So now we all know that Fg is along the x is simply our mg sine theta equals mass times acceleration, and that is negative. Okay. Now, in order for us to solve for acceleration, we can say that that is negative mass mg sine theta divided by mass, and now we can cancel our m. So what's left is negative g sine theta. So this is our answer for letter A, and our answer is negative. Yes, it's negative because it's moving to the left side. Since it's moving to the left, the direction of motion is to the left, therefore we can say that it's negative acceleration, not just because it is moving slowly, right, or starting to slow down. Now, to be exact, if we notice that g along the surface is always negative because of the direction, so we can actually put what? Negative multiplied by negative g sine theta, because of the direction is always towards the center of gravity. So that's negative and negative, so we can also cancel it to positive g sine theta. Okay. G sine theta. So it's either negative g sine theta, or we can just say A is the acceleration due to gravity multiplied by sine theta. So that's for letter A. Now, what is our minimum angle? So what is the minimum angle? And then it will start moving. What is the minimum angle for us to start moving? So it's simple. All we have to do is use the same equation right here. Use the same equation from A in terms of A. So you have option. It's either you use this A, or we can start using this section right here. So we can start using the section right here where it says mg sine theta, or we can just move on with this section over here, because whether we like it or not, the masses will cancel because mass is mass. So we can just use the same equation right here, which is A equals g sine theta. So by copying this equation for letter B, we can say that A is equivalent to g sine theta. I want the angle to be by itself on one side of the equation. So all I have to do is divide both sides of the equation by the acceleration due to gravity, and that is A over g, and this is sine theta. Now if I wanted to, I just wanted to make sure that it looks nice and organized, so I can say that sine theta is the same as A over g. Sine theta is A over g. Now we can say that sine or theta is simply the arcsine of the acceleration over the acceleration due to gravity. So this will be our answer for letter B. So what is the minimum angle? So it means that at how high, if there is no friction on the plane, on the inclined plane, at what angle will it start sliding down off the ramp? So this is the condition when we don't have friction.